We're going to jump here to the course webpage. Again, you should be able to see this site yourself. And our lesson overview for each week will basically be the starting point for you to get a sense of what we're going to cover in the course that week. The lesson overview generally has a short summary of what the main focus is for that week, a list of the learning goals, and then also if we have lesson videos, which normally we will post after each of the online sessions that we have on Wednesdays, might take us up to a day or so to get those up, but generally they'll be up the following day. If there's lesson videos, you'll find them in the lesson overview as well. And here there is one video about this good coding practice number 1 that is a lecture video from last year, but really nothing has changed, so we saw no need to replace it. In this case of the first lesson 2, there will be some lecture slides, those that I presented a moment ago. Those lecture slides will also be linked as a PDF here. So the lesson overview is sort of the starting point for each week. There's a few things we should cover before we get into our Python lesson, and I'm sorry that didn't remember to bring these up earlier, but we have some course environment items that are worth presenting to you here and now. And this is basically stuff about how the course operates. We're going to throw kind of a lot of technology at you here in the first week, and it might take you a week or so, or maybe a few weeks to get comfortable with all the different names and different systems we're using for the course. But all of them have been chosen not only on the basis of what we felt would work well in this course and based on many experiences from having taught this course, but also based on being tools that are used by professional software designers. So what you will see here on the course environment is a description of the course and the way the web page can operate, starting with interactive code cells. These are a new feature that we added last year to the course. And if you go to any of the lessons, really later on in the course, the first week only has one page that will work with this, and that's our Taste of Python lesson. But there's a way in which you can click a button. So I'll just open the Taste of Python lesson page so you can see it. There's this little rocket ship up here at the top. And if you click on the live code button, that will turn this page into an interactive page that you can use within the web browser. So you'll see this thing pops up, says launching from mybinder.org, fetching. It takes a moment, maybe a minute or two for the page to become active, but then you can interact with the web page itself. All of our lessons are basically designed in this way so that you can interact with the website. In truth, it's not necessarily what we suggest doing, but the option is here. And I'll just demonstrate it very quickly so you can see how it works. In case you ever want to test something quickly, you can do it pretty easily this way. I think normally the MyBinder will launch even faster than it is now. It normally is cached, and so it should take about 30 seconds to become live. Right now, it's doing some kind of cloud computing stuff in the background that might take a minute for it to become usable. But while that's doing its thing, I'm just going to scroll down here to an example. So what we have in our first lesson is an example of some simple Python math. And by clicking on that button to make this web page live, I can now go to these places where there was an example of a Python calculation like 1 + 1, and I can change that to be, for instance, 2 + 2. And I just need to see whether this thing is ready to run yet. Still building. So when I click the run button, it's not going to do anything yet because it's still preparing. So I don't think this is, it says it's just waiting. But as soon as the background cloud computing system is ready, then you would be able to run this cell and it would do some calculation for you. I don't want to waste time just waiting for this to come up. In the future, once it's been launched once, it usually comes up much more quickly. So it should come up more quickly for you as well. But we have this interactive code cell option, and we can jump back over there and see whether our 2+2 worked out in just a moment. We're going to be using for our Python programming environment a system called Jupyter Lab. It's a web-based system designed really for data scientists in mind. But essentially, it combines two things that are very commonly used by programmers, and that is some environment where you can generate text and documentation, and some place where you can put code and also have the outputs from your code in the same interactive document. And this will become clear when we start working with Jupyter Lab, how exactly it all works together. And I'll say you can also read through this description on the course page if you want a little bit more. I think I could read you this, but it's probably better that we just move forward and get closer to you actually using these Jupyter notebooks, where you'll see how things work in general. But basically, we have a web application that will come up. In the web application, we have the ability to have these different notebooks, is what they're called. And so here's an example of what one of the notebooks looks like, where there's some nice looking text, and then there's these cells in here for where you contain some code, and you can then run the code and get your outputs displayed on the screen. For the cloud computing, this is something that's basically needed to run this Jupyter notebook system. You need some kind of computing environment. We have some options for cloud computing here. One of them is to use a system called Binder. And Binder you can open by basically clicking on that same little rocket ship and then clicking the Binder icon. That will open a interactive Jupyter notebook using the Binder system, which is great. It's fast. You don't have to log in or anything like that. But you have about 10 minutes of inactivity in Binder before the system will shut down what you're working on, and you'll potentially lose your output. So you can continue to interact and use your Binder session without a problem. But if you stop for about 10 minutes, if someone calls you or you go to have lunch or something like that, then Binder will detect inactivity and basically shut the system down. It's a free resource, so they don't allow this sort of infinite use of this cloud computing system through Binder. But you can find a little bit more information in the description of Binder here. I will skip through that in lieu of saying a bit more about the CSC notebook system, because this is what we strongly recommend for the students in the course. It is a resource provided by the Finnish IT Center for Science, or CSC. And this is what we will be using in the course for hosting our notebooks. There's a website that you can click on to go to notebooks.csc.fi. And when you go to the site, you can log in there. You should be able to log in with your Haka authentication or University of Helsinki login credentials using the Haka login. And then you will go and you'll find an account tab there. And this is something we need to set up one time in order to be able to use this system. And I think maybe this is a good time to do things like this right now. So if you click on this link to go to notebooks.csc.fi, you will come to an environment that looks something like this. It won't look quite exactly the same as mine because I have the sort of administrator view, and you won't probably see Geo-Python 2021 in your list of the environments, but you may see something like course introduction to Python or course introduction to R and things like that. If you're not seeing that stuff, please put a message in chat once you've logged in, or if you're having a problem logging in, let us know. Anyone who has an active account with a Finnish university should be able to log into this system using the Haka authentication. Once you have logged in, the idea is to go here to Account. And if you click on the Account button, you should see user groups. I see one right now for Geo-Python that I'm a member of, but you will most probably not see this. And so what you'll want to do is click on the Join Group button, and then you'll be asked for a joining code. The joining code can be found here on the course webpage. It's geo-python Python-TAD, is that L or 1? 14. I'll paste it here in the chat. So you can copy paste that joining code into the little dialog box here, asking you for the joining code, and that will then allow you to become a member of the Geo-Python group. And I did not join the group, but I'm already a member, so who needs me to join anyway? But at that point, once you've joined and you see yourself here as being part of the Geo-Python group, if you go back to dashboard, you should now see not this view, but rather this view, Geo-Python 2021 and Geo-Python 2021 Lite. And you can then click on the Launch New button to start up your instance or your cloud computing environment for working on today's lesson. So I see a bunch of those coming to life now. And yeah, as they come to life, you're welcome if you're having problems. Yeah, someone's asking about the link to the CSC Notebooks. That's, I could paste that. Do we need to turn on notifications for CSC? You might want to. The only reason is I think you do get a notification when your instance is about to be closed. So if you have something you've been working on, normally what happens with this computing environment is you start up a session and it has a 6-hour lifetime. Once it gets to the end of the 6 hours, it will be terminated no matter whether you've saved your work or not. And so it may be beneficial to have the notifications turned on just because I do believe it gives you a warning. I don't remember if it's an hour beforehand or maybe closer to when it's going to turn off. But there shouldn't be many other notifications that come from the CSC Notebooks. But it's good to know that your session is going to be shut down so you can make sure you save your files. So I see a whole bunch of these coming to life. Again, if you're having trouble, you can say something maybe in the chat. But once you have launched your session, you can click open in browser on your session. I guess you probably only see one. I see them all because I'm the sort of administrator, and I am going to open this Geo-Python 2021 Lite. I don't suggest you do this, but I'm opening it just because I have a problem with files on my Geo-Python 2021. But you should open up this one here, the one that does have storage. I'm opening this only because I have an issue currently with my files that are stored from last year, and I can't see this year's data files in the new Python environment. So those are all coming open. We'll let them open in the background. And again, once it's ready, you can click open in browser, and then you'll be, I think, given some pop-up that says, here's some password you can copy, and you just copy and paste that into the little box that comes up. And then you should see a, let's see here. So yeah, you get this little pop-up thing here. It says you need to copy the password and proceed. And then you just paste that password that was copied into the login box here. That will make sure that your session that you just opened is what you connect to and not someone else's. And if all goes well, you should see something like this. Yep. And it's okay if you've got that open, we can just leave that be in the background for right now. I'll show you a couple other course environment things, and then we'll get to our lesson itself. So yeah, everybody should hopefully be opening up the CSC Notebooks. You can also install this Jupyter system on your own computer. We have instructions on how to do that. It's advisable, at least for the first couple of weeks, maybe to work with this CSC Notebook system, and then you can determine if you want to install it on your own computer. It's not a huge process, but we assume more or less that people are using the CSC Notebooks. We'll talk more about Git and GitHub next week when we introduce version control. But essentially, this is the place that allows us to keep track of changes to the files that we're working on, to changes to our programs. So we'll come back to that stuff. I don't think there's a need to say much about it here, but you can read about Git and GitHub on the course page if you're interested. You've already experienced the voting and polling part. We'll periodically use these polls. In fact, most of the time we'll start class with a poll about how things have been going in the past week. And of course, we're using Zoom. And next, we can maybe say a little bit about the Slack system. And I don't know, I think Håvard was going to say something. Do you want to share your screen as well?
Yeah, I can do that.
Okay, so maybe I'll stop sharing and then we can jump over to something about the Slack.
So if people can see my browser now, that would be great. So I'm just taking off at the same place that Dave left off. And so here we are, if we click on read more about Slack, there is the page where we describe how we use Slack in this course. And so you should have gotten an invitation link, and I see that a lot of people have and already started logging into Slack, and that is great. So when I can just go quickly through how we have set up our Slack room. So if we click on the link, we get into Slack here. This is, for those who haven't used this is how the general feel of how Slack is used. There are the different channels on the left. This is a general channel for everything general about the course, like Dave has posted the essential links that we are using here. And then there are different channels for different for each week, for the different exercises and materials, where you can post questions and help answer other people's questions. So we encourage you to be active in the discussions on Slack, not to post the coding answers or the correct solutions, but to ask questions and help other people in how to think to come to the correct conclusion and the correct solution to different problems. So here you can, so if you don't see the different channels for each week, you can go to more and find all the different channels that you can join. And if you have had issues with CSU and enrollment, we've created a separate channel for that you can join, and we'll proceed with that process there. Yes, so that's in general how Slack works. So encourage you to just be active there and post questions and enter discussions. Basically. So I can go back to, so that's the basic usage, how we have set up the different channels that we use. And then, we can go through, you can ask different questions and write in the message box in the bottom. And I see that Jeppe has not found the enrollment channel, and I can also add people to the channels. But if you're still, there's in the more, and you can open the channel browser, and they should all be here. And you can go to the different channels and write here. And if you want to write to a specific person, you can add them, and then you will get notified about things or about that message. Here is the new channel, and then you can reply in threads, so that keeping each discussion organized. You can then pop out here, and then it goes up to the right, and and then Dave replies here in the thread. All right, so that is the short version of how to use Slack. So we encourage you to be active, as I said, use the threads to keep everything organized, ask questions to other students, to us and the teaching assistants, and discuss and comment. But don't provide like the solutions to the coding problems in the Slack discussions, as it is a forum to discuss and try to encourage learning and not just finding the solutions right away. Yeah, I think that covers Slack for now. So I'll give it back to Dave.
Yeah, thanks, Håvard. I think you're exactly right. That covers what we need for an introduction to Slack, and you'll, I think, find it to be fairly intuitive as you start working with Slack a bit more during the course. The main thing I just want to emphasize here with Slack is that part of the reason why we want to do the communication in Slack is so that when questions get asked by you, that everyone could see the questions that are being asked and everyone could see the answers that are being provided, with the idea that those are kind of general questions. If you have specific things that you want to talk about where you have, here's my code, I can't figure out why this doesn't work, then it's better to directly contact one of the course instructors or teaching assistants. As Håvard has already mentioned, we don't want to have you posting the solutions on the Slack channel. That's not so helpful for learning outcomes, although maybe it's beneficial if you're really busy that week. But anyway, returning now to the idea that I've teased you with, that we would do a little bit of Python programming this week, we can now jump to our Taste of Python lesson. You'll find it on the course page here, and the version that's on the course page will have all of the cells already filled in with the solutions that are going to be typed in. But what I would encourage you to do is actually to go back to your CSC Notebooks if you have that tab open somewhere. And this is one of the things that's a little bit tricky with how the course runs now online compared to the earlier version where we all sat in a big lecture hall. It can be sometimes a bit difficult to follow what I'm showing you on the shared screen here, while at the same time trying to do something in your own notebook on your own computer in the CSC Notebooks system. So it might take you a week to come up with a clever solution to this, but I know some people last year were like watching the lecture stream on their phone while using their computer to work on the exercise, or doing something similar. If you've got two screens, you've got a solution to this problem perhaps right in front of you. But I will say that it's ideal if you can see both my screen and be interacting with your notebook at the same time. But hopefully, if you've opened the CSC Notebook system, your view looks more or less like what mine does right now. And what we're going to do is go into this folder on the left side and double click on the Notebooks folder. And then within that folder, there is another called L1. And if you double click on that, that will take you into the directory we're working in for today. And our file that we're going to open is this top one called A Taste of Python, which you can just double click on to open. If you're having any issues with that, again, please post them in Slack, or Slack or the Zoom chat, either one, I suppose, both will be monitored. Now, in here, we have our first example of a Jupyter notebook. Hopefully yours looks more or less like this. So there's a little bit of descriptive text here that tells you about what this lesson's about, some information about this document itself, that it is a Jupyter notebook and how it works. The main thing you need to remember at this point is that in order to run a code cell, you can press Shift and then press Enter, and that will run the code cell. Or you can click on the little play button at the top when you have selected a code cell. We'll see how that works in just a second. You are probably already running on the CSC Notebook system, so this might not apply, but if you're running Jupyter Lab on your own computer, you'll have to type in something like this in a terminal window to get Jupyter Lab to open. But what we're going to do is just get a little introduction to some things in Python in the first bit of the lesson today. And we're going to start very simply with some Python math. And that is what we can do here in our code cells. So you can see the cells here above might not look like there's a cell at all, but that's what these are called within a notebook. The code cell, I think, maybe looks a little bit more like a cell. It's a box here. And we can type into our code cell 1 plus 1. And then if you either click on the play button or the top, or you press Shift, Enter, you should see that your notebook does the calculation of 1.1 or 1 plus 1 and displays a value of 2 underneath the cell. We could also do something a little bit more complicated and do 5 times 7. So multiplication is done with this asterisk symbol. And again, if you press Shift and then hit Enter, that will run the cell, and you should see the output here of 35 as expected on the bottom line. So that's how the code cells are working. Once you've run a code cell, you have a couple things that are visible to you. One is that the order in which they're run is visible. So if I've run this cell here, and then I've run this one after it, they're labeled in consecutive order. And if I decided that, well, I don't really care about 1 plus 1, that's not that interesting, but I want to do 1 plus 3, I can change this value to be 1 plus 3. And then when I run the cell again, I get a new value that's calculated here. And I can also see that my numbering has been updated to show that even though these are not in order this way, I ran this third and ran the one beneath it second. So that's handy because sometimes you might want to check and see which cells you have already run. And those that have not been run yet will have nothing in the square brackets. Those that have been run will have a number there, and you can then tell which order they have been executed in, which might have some impact on your output. So that's the basic math, no big surprises there. We can also use some functions in Python. So there's things like the print function that will display values to the screen. We could also think of some other functions here, like using a sine or square root. So we could do sine of 3. And what you'll see if you run this is perhaps somewhat unexpected output. Same thing if you do sqrt, that's square root of 4. You might expect to see a value of 2. But we actually get this name error output. And this is something that's basically telling us that, well, I see you're trying to do some calculation, but I don't actually know what to do. But the Python interpreter doesn't understand what we've suggested it should calculate. And it may concern you at this point that Python can't do these kind of calculations. Well, it can, but it's not part of the basic math operations that are enabled by default in Python. So what's enabled by default when you launch Python is very much stripped down to these simplest of math operations that are summarized in the table here as math operations. So there's addition, subtraction, multiplication, division, and the one that's even difficult for native English speakers, exponentiation. It's a very unusual word, but raising something to a power, basically. And there's some examples here that are shown in the table to see how those all work. If we want to do fancier math than that, if we want to calculate something like the sine of a value, if we want to calculate the square root of a value, we need to bring in a special library or module called math that will allow us to do those kind of math operations. And we can do that by typing import, which basically is going to tell Python to read in a library of additional tools. And we're going to import something called math. I will do Shift Enter to do that. There's no output here. It's just reading in these math functions that are going to be available in the computer's memory now. And if I want to use them, the way I would do it is I would type math and then a dot and then the name of some function, like math.sine of 3. Now, when I run this, I get a value back of 0.1400, whatever, 0.14112, blah, blah, blah. Now, I don't actually know what the sine of 3 should be. That looks about right because the sine of pi should be 0. So it's close to a value of pi. Looks pretty good, but I do know that if I do the math dot square root of 4, that I should get 2. And when I run that, sure enough, I get 2 back. So the key thing to take away from this is Python can do this very basic math by default, sort of it's ready to roll when you launch up a Jupyter Lab session or open a Python interpreter. You're ready to do the basic math. But if you want to do anything fancier, you want to calculate cosines, tangents, square roots, absolute values, those are going to rely on using a different math library that you could import this way as import and then the name of the library. And then you could do the library name dot and some function that's part of that library, like .sign. So if I tried to do math.sign with an E, I'm going to get another error message here because this is not the name of the sign function in the math library. It's math.sin. And when I run that, there's no problem. So just be aware, if you're getting kind of unexpected behavior, like, hey, I should be able to calculate the sign, it may be because you've typed the name of the function in incorrectly. So we can deal with many of these different libraries, and we will later in the course handle many of the different libraries. But for now, we're just dealing with the math library that has a bunch of functions related to mathematical operations. In addition, it does have values that are stored in memory, like the value of pi. So if I type in math.pi and run this cell, you'll notice there's no parentheses here. It's just math.pi. That's because this is a constant or a value that's stored as a constant in the math library of the value of pi. And when I run that cell, what's output is the value of pi with, 16 digits of precision or something like that. So at this point, just to check and see that you're following along and see that everything is going okay, we have a little check your understanding cell here where you can use this empty Python cell to calculate the sign of pi. And again, you might think, what is the value that I'm expecting to see? Did you get the expected result? Do things work as they're supposed to? And once you are finished with that, let's see, what have we got in reactions? Maybe you can give a green check mark in Zoom. So if you go to, I don't know exactly what you see, but you should see some reactions thing. If you don't see it, it could be under the more in the Zoom toolbar. And if you go to reactions, you can then just do the green check mark when you're finished with your calculation of the sign of pi. And once we see a decent number of green check marks, we will continue from that point. What we were asked to do here was to calculate the sign of pi. And as we saw, in order to calculate the sign of some value, we have to do math.sign, S-I-N, as the name of the function we're going to use. And then you can have an open parentheses here, and the value that you want to calculate should go inside here. And in this case, we are going to just put in math.pi. So the simplest way to do this calculation is to do the sign of the value of pi that's already stored as part of the math library. So math sign of math.pi. And you can put spaces here if you want to. You don't do that for using functions, but if it's easier to read, you can include spaces here. Python doesn't really care about the spaces. But if you run this, then the value you get back here is 1.22 blah, 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 times 10 to the minus 16. Now, you may be somewhat surprised to not get a value of exactly 0 because the sign of pi is 0. But this relates to the way in which the memory of the computer is storing these values. And then you can see this number is very close to 0, but not exactly 0. And that's potentially because the value of pi itself might be rounded off in how it's stored in memory. So the exact calculation doesn't give you back 0. Or it may be that just the value that's calculated here is very close to, but not exactly equal to 0. we could go into the details about that at some point, but the basic idea is that for numbers that are decimal values, the computer has a difficult time to store something that's exactly equal to 0. It's often very close to, but not exactly 0. Okay, so are there any questions about that, or anybody ended up with something totally different? Okay, looks like there are still a few issues in the CSC notebooks. We can reserve a bit of time after the class, hopefully, as well, or on Slack to help with debugging some of these things if we can't find a solution currently. But yeah, we should move forward now because I want to reserve a little bit of time at the end to talk about the exercise for this week. So to go moving here, when we talk about our functions, it's possible that you can use more than a single function at one time. So if what we wanted to do was to print out the value of the square root of 4, we could use a function we haven't used yet called print. And inside here, we could do math.sqrt and then the value of 4. Now we have one function here, the square root function, so we have a pair of parentheses there, and it's inside the print function, so there's another closed parentheses there. You have to have balanced parentheses on the lines, but this will print out the value of math.square root of 4 when you run the cell by pressing Shift Enter. No big surprise here, we get a value of 2 back. It doesn't look that much different than if we just deleted the print statement entirely and just ran math.square root, we get actually basically the same output back. So you might be wondering, well, why bother with that? Well, the difference here is that we could say print something like 2, or the value of, or let's maybe just do it like this. The square root of 4 is, so we have some text there, and then math.sqrt of 4. So now I have some text that's enclosed in quotation marks. You can use single or double quotation marks, doesn't make a difference in Python. But the square root of 4 is, and then comma, math.square root of 4. And when I run this cell, now I see the text printed out. The square root of 4 is 2.0. So this is one of the ways in which you might consider combining functions, that we have a print function to print some text plus a calculation that's done inside here with the math square root function. Okay, so everything we've been doing so far has basically been a calculation that's been printed out to the screen or displayed on the screen, but we haven't actually stored any of these values in memory. And we can store them in memory by assigning a value to a variable. And a variable is basically a way to allow us to refer to a value more easily and in a more intuitive way for our memory as we're working in some program. So what we could do for an example here is define a variable called temp_Celsius and set it equal to a value of 10.0. And if I run this cell, you don't see any output, but something has happened. I can see there's a number here that's been executed. And what has happened is the value of the variable called temp_Celsius has been stored in memory as being equal to 10.0. Now, if I go up here to the bar above the notebook window, there's a button here with a plus sign. I can click plus, and that will add a code cell underneath the one I just had used. I could also modify what's in this cell, but I'm just going to add one as an example of how to do that. And now if I wanted to print out temp_Celsius, if I run this cell, now I see my value of 10 printed out to the screen. So basically, I've just taken this value and given it a different name that allows me to more easily understand what that number is meant to represent. Now, the same thing that we did earlier, where we combined some function with some text, we could do here. And we could also, in this case, do a little bit of math to convert my temperature from Celsius to Fahrenheit. And we can do that by, again, using the print statement. We'll print out something that says temperature in Fahrenheit. You can just put F if you don't feel like typing in Fahrenheit. So that's our text that's inside of a set of quotation marks, temperature in Fahrenheit. And now we're going to convert this temperature, and we can do that by multiplying our temp Celsius times 9/5, and then adding 32. So if we say 9 divided by 5 times temp underscore Celsius plus 32, that's our conversion from Celsius to Fahrenheit. And then add my close parentheses here. And if I run this, I get temperature in Fahrenheit 50 degrees. And intuitively, that seems about right. I can see here that I was expecting to get a value of 50 degrees, and so that's good to see. All right, so we have another opportunity here to check your understanding at this point. So there's a Python cell below here, and what you should do is define a variable and print its value to the screen using the print function. And it can be anything you like for the variable value that you define, and you can print it out. And once you're done with that, I'm going to clear away all the green check marks. Once you're done, you can add a green check mark to indicate that you are ready to continue. So the task was to print something out to the screen that you've assigned to a variable. And I give a nice example here. And we could say maybe a variable called part1 equals I like. And then part2. Python, exclamation mark. So we have I like and Python, and then if we just use a print statement to print part1 and part2, when I run the cell, I'll assign these two variable values and then print them to the screen to get I like Python. So silly example, of course, but just to give you some idea of how that all works. Now, there is the next section here about updating variables. I'm going to go through this just very briefly because I want to move to some other things and make sure that we don't totally run out of time for the preview of the exercise. But the main point here is that our variable values like temp Celsius are not fixed, but can be changed. So I could say temp Celsius equals 15. And if I print it out to the screen, something like temp Celsius is now. So if you just want to follow along watching for right now, I'm going to apologize if I'm typing a bit quickly. But of course, as expected, when we change the variable value and print it out to the screen, we see a different value that is displayed. Now, if we were to do something silly here, like try to print out a value like temp Fahrenheit, if I just print this out to the screen, of course, I get a name error here, and it indicates that temp Fahrenheit has not been defined. And if I wanted to, I could then define my value of temp Fahrenheit and then run my print statement again. So I could say, for instance, temp Fahrenheit is equal to 9 divided by 5 times temp Celsius, like we did before, plus 32. So now that will assign a value to a variable called temp Fahrenheit when I run this cell. And if I go back up and now try to print this temp Fahrenheit value out, I do in fact see the value of temp Fahrenheit as expected. So that is updating variables. I'll skip this last little cell. You could print out both the temp Celsius and temp Fahrenheit together if you like, but I'm just going to skip it in the interest of time. So apologies, we're running a little bit behind the expected schedule. The one other thing that's worth noting here is that we have an equation where we've calculated the variable value temp Fahrenheit. If I change temp Celsius to be equal to 20, and then run a print statement of temp Celsius and temp Fahrenheit, just run those two things together to print them both out to the screen. The value of temp Celsius is changed as expected to be 20, but the value of temp Fahrenheit has not changed. So this is not like Excel, where if you had referenced the cell containing the value of temp Celsius, it would have automatically recalculated temp Fahrenheit. Temp Fahrenheit was calculated at this time using the current value of temp Celsius, which was 15 at the time, not 20. And of course, its value has not been modified since we have not recalculated temp Fahrenheit. So a few things here now about data types, because we're going to encounter them sooner or later. There's different types of data that can be represented in Python. There are 4 basic data types that are shown here. So there's int for whole integer values, like the number 4. There's float for decimal values. str, which is for string. That's for text, basically, character values. And then bool, which is a true or false value. And we can determine which kind of value that we're dealing with using a function called type. So if I assigned a variable here called weather forecast and set its value to be equal to hot, well, that's not necessarily very accurate. Let's call it cloudy, because that's probably closer to what we're experiencing. If I assign that value and then run the type command, the type function on weather forecast, what I see is I'll assign this a string value called cloudy. And when I run type, of course, it comes back with the variable type being equal to string. Now, you might wonder why this matters, what kind of data we're dealing with. And the reason is that if we try to do something like if we try to do something like take our weather forecast variable we just created, weather forecast, and add that to something like temp Fahrenheit, we're going to have a problem. And the reason is that what we've asked the Python program to do here is to take a string value, cloudy, and add it to some numerical value. And it's not really clear in Python what we're actually trying to ask the computer to do. So it says can only concatenate string, not float to string. So it's saying I can't take a decimal number and just add that to a string. Do you want me to like make it say cloudy and then whatever the value of temp Fahrenheit was, cloudy 59.0? Or did you somehow want to add the numbers that are represented in this word cloudy to 59.0? It's not clear. And so we get this type error that's telling us basically the data types you're trying to combine, they don't play together nicely. So that is, that's one issue that you'll commonly experience here is you have incompatible data types. Now there's another spot here to do another test and to play around a little bit with Python variables, and you see, which kinds can you combine, which kinds you can't. I would say we save that as an exercise for you to do on your own. You can try and do this, and maybe you'll learn something useful just from playing around with the different data types to see which ones are compatible and which ones are not. But since the last thing here is part of the exercise for this week on character input, I should probably show you how that works so you have some idea how things are working. The way this works is basically there's an input function that's built into Python that allows you to prompt the user to assign a value to a variable. So we could do something like, say, place equals, and then we're going to give it a function called input. And then we'll give the input function a text string called where are you from? Okay, make sure that our quotation marks are both balanced and parentheses are both balanced. And underneath this, we can print. And we'll assume that everybody's from a nice place here. We'll print out place is a nice place. Hopefully that's true. Now, when I run this cell, press Shift Enter, you can see I get this little box that says, where are you from? And so I could say, how about, I'll say the state in the United States where I'm from, Michigan. When I then hit Enter, that value will be stored in the variable called place. And then what we see is the print statement gets executed after that that says, Michigan is a nice place. And sure enough, Michigan is a nice place. So this is a way in which you can basically prompt the user to fill in a value as part of a kind of an interactive program. Not used that often, but it's a useful, fun thing to play with when you write your own first little programs. Couple warnings here. One is that sometimes the Jupyter notebooks get a little bit mixed up. This input statement is not something they're really designed to use. So if you're having problems, you can go up here to the top where it says kernel and click restart kernel. I don't advise you do that right now, but if you are having problems, that's how you can get things back to working properly, is by restarting the kernel. And in addition, the course web page looks like crap where these input statements are, because basically when we generate the course web page, we don't have a way to provide the prompt for the variable value that's there. So then it comes back saying it's empty and gives a bunch of nasty looking error messages. So sorry if the output on the course page doesn't look so nice for this input function. But that's kind of the end of the introduction here. There's a few more examples of using the input function here that you can find at least a description of how it can work on the course page. The output again doesn't look very nice, but you can at least go through and do the rest of the exercise if you would like, using what's available on the course page. Are there any questions at this point about our introduction to Python? Sorry again to kind of rush through the last piece of it here, but maybe there's a question.
Will the next Zoom links be linked in Slack?
So we'll use the same Zoom link each week, and I think it is already in Slack. If you go to the general channel, I'll just drag this down here. So there were some questions about whether the Zoom sessions would be recorded and things like that. But up at the top of the channel, there's a pinned post here that has a link to the course website, a link to the course Zoom, and then one thing that we haven't talked to is about this work session. And so maybe let's do that now quickly before we go to the exercise. So as noted, we're going to do these hybrid work sessions on Thursdays and Fridays. There have been a number of questions, like in the chat and elsewhere, about how that works. I think in CSU, you're just assigned to one or the other, or maybe you can choose, I don't remember. But I think it's not really making any difference which one you're signed up for. You can come to either one of the work sessions, whichever is more convenient for you, and they're totally optional. So there is no need to attend them at all if you don't feel it's beneficial. For those of you who do want to come in person, there is this link here, and if you click on it, it will open up a spreadsheet on the online Excel system, where you can mark with an X the time that you would be attending one of the sessions here. And I guess when I put this course video, we normally make the videos available on YouTube. I'll try to cover up people's names just so that if anybody's name is here, like Eleanor, that we can cover up and not have your name displayed here if you don't want it. But the point here is that this allows you to reserve a time slot or time slots that you're going to be physically present if you're going to attend an exercise session in person. We have 14 seats available in the classroom, and the idea is that you can look over here on the right side and see for the different times how many spaces are still available, and you can then fill in things there. It does rely on you being kind of good citizens and putting in your own name and not deleting someone else's name or changing the times they've reserved. I've given you the power to have editing access for this spreadsheet. And so with that power comes the responsibility to be good citizens. The Thursday tab is here. If you click on the bottom, you can see the Friday tab there. And then again, people can just reserve which times they plan to be physically present in the classroom. And I think the classroom itself, maybe the information's not here, but it's in CSU. It's the GIS classroom in the Physicum, which I think is A113, 114 or something like that. But you should check in CSU to see the classroom. But yeah, please don't modify any of the stuff over here on the right side. Only do things like add your name and then use an X to indicate the times that you think you would be present attending the sessions in person. If you're attending online, there is no need to do anything with this spreadsheet. This is only for people who plan to come to the classroom in the Physicum building. And again, you'll find that link in Slack. I think what we'll do is like each week on Monday, we'll just clean it out and then you can sign in that or yeah, I think that's probably the easiest thing is we'll do it on Mondays. Okay, going to jump back here now to the course page. So the last thing for lesson 1, sorry, we're going to go a couple minutes over our, I think we're supposed to end at 11:45. We're not going to quite make that, but if you go here to exercise 1 on the course page, you'll see the description of what you should do for the first exercise. It's not super heavy, but this will take a little bit of time. So just be aware that you might need to reserve a bit of time to work on this exercise. The exercise each week will be due by the start of the next lesson. So it's assigned today on Wednesday. It's due by the start of class next week on Wednesday. So that'd be the 15th that this one is due by the start of class. For the first exercise, you have 2 kind of administrative tasks, I suppose. One is to sign up for GitHub. So you need to go to github.com and create an account there. We're going to be using this GitHub site for the exercises in the course. It's really not possible to do the course without having a GitHub account. So please go and sign up for GitHub using the instructions that are listed here. Then once you've signed up for GitHub, you should go to our Slack page, which hopefully you have already joined, and go to the week 1 channel and post a message that has your full name, your GitHub username, and the course code for the course that you're registered for. So for example, Dave Whip, and then here's my GitHub name, and then the course that I'm responsible for in this case, or Håvard has his example here as well. If you're from a different institution like Aalto, I don't think we have anybody from Turku or Oulu this year, but you would then just put your name and you can just list whichever university is there. This is going to help us with organizing who is paired up to work with one another. I'll talk about that in a second, but also to make sure that people are working with students from the same university as much as possible, which might make things easier if you choose to meet in person instead of meeting online. And then lastly, you have a little exercise here to do where you should go and do some Python stuff, cook up some Python of your own. There is an exercise that's described here. So you're going to make a copy of this in GitHub. You'll see how to do that. And then in here, there's some things to define some variables, read in some values, do a little math, check the data types, and then print some text out to the screen. And basically it tells you exactly what to do. And then you can save your files to GitHub. So it walks you through the instructions of more or less how to do the exercise there. I think in terms of what you have to submit, basically you just have to do this post to the week 1 channel in the Slack, and then save your files that you've modified in GitHub, and you will you'll see some instructions about how to do that. Let me see. I think maybe I need to show you one thing here in order to be able to do the exercise. So you need to open up some Jupyter notebook system. So it could be through the CSC Notebooks, for example. But one thing you're going to need to do for the exercise this week is to create a new notebook. So when you open things up, you'll be somewhere like here. Maybe you want to go into the exercises folder and make a directory in there for your exercise for this week. But regardless, what you want to do is click the button here, this blue plus, that opens a new launcher, and then you can choose that you want to make a new notebook, or you can go to File, New, and then choose Notebook. That's going to create a notebook, and it'll ask you which kernel. You can just hit select. It doesn't, there's only one available, so you just choose that. And this makes your new notebook where you can fill in your answers to the questions that are asked for you, or asked of you, I suppose. Now, it basically tells you more or less how to define things. And I think in this case, we don't do anything where you have to add in any kind of additional fancy text or anything like that. So basically, you're just going to be assigning variables in here, whatever. I'll give it some real name, like dog name, and equals Woofy with an exclamation mark. So we could assign our variable for the dog name named Woofy. And the key thing in here, once you've made this new notebook, is you're going to be asked to save it with a certain name. If you just right click on the tab, you can go to rename notebook. I think you can also rename the notebook over here in the file browser. There's a rename option here. And I think you're supposed to call it like exercise 1 or something like that. To be totally honest, it doesn't matter so much whether you rename it, but the important thing here is that you're going to have to copy this file to GitHub, and we have not taught you yet how to do that within here. We'll talk about that next week. There's a way to do this within the notebooks system. But if you don't have the notebooks system available for doing Git stuff yet, which is going to be the case for you, you need to go here and then go to, I think it's saved notebook. Not finding, no, it's download, sorry. So you go to File, and then to download the notebook, that'll put a copy on your computer, and then you can drag and drop that to GitHub to upload it. So you need to go to File, Download, to download the copy of this notebook. So it's exercise1.ipynb. That's the file extension for a Jupyter notebook. I save that, and then it pops up over here in my list of downloaded files for me to then be able to drag and drop to GitHub. If you're having questions about that, the course assistants will certainly be able to help you with uploading your exercise to GitHub for this first week. Beyond that, I thought I had one other thing about the exercise. Yes. The one other thing is that we have a pre-course survey, which is, I suppose, a week 1 course survey, where we'd like you to fill in some basic information about your past programming experience. We've asked in the poll already, but we want to get information from everybody. So for the students who weren't able to join us in lecture today, we want to know about their programming experience, as well as if you have a preference for who you would like to work with in the course. So if you click on the link, it opens up an e-form that looks like this. It'll be open until about 1 o'clock next week. You can fill in some basic information here. Do you have access to a computer and reliable internet connection? Which course are you in? Some information about your programming experience and which exercise session you're more likely to attend. This also helps us in pairing up people to work together. And if you'd like to work with a specific person, if you have a friend in the course you want to work with, you can put their name in here. And if you have any questions or whatever, you can fill them in the additional information box there. For the first exercise, you're going to be working on your own. And later in the course, we're going to put you together working as a pair, because one of the challenges of working remotely for this course is that it's hard to find questions or get answers to questions as easily as you might when we're physically present in a classroom. So last year, it seemed to work out quite well to have people working together in pairs, and we're going to try and do that again this year. So we'll talk more about the pair programming when we get to that week in the course, when you're going to be asked to work as a pair. But for now, we just ask that you, as part of this exercise, fill in this e-form. And again, I'll put the link also in Slack to remind you to please fill that in before class next week. So I feel very much like I have buried you in information. Håvard has probably been witness to this burial and may be sharing some kind of bystander guilt or something like this, because the first day of the course is a lot of new information. But the course webpage explains much of it. And if you're confused about things, we encourage you to first have a look at the course webpage, read things through. And if you have questions, you're more than welcome to post them in Slack or contact us directly. You can also send direct messages in Slack. I don't remember, Håvard, if you showed that example. But if you're in the Slack, I'm in the app for Slack for this case. But if you're on the webpage or whatever, it doesn't matter. But you could go here, for instance, to my name, and you could click on my name, or maybe I could click on Håvard's name just as an example. And then I can see in here, we've already had some conversations, but I could send him a message directly. And if you'd like to, if you have a question you don't feel like you want to share with everyone, you can also send us direct messages in Slack that way by clicking someone's name and then sending some message that would then be private just to that person. Do you have any questions at this point? Normally, I would look around the lecture hall and see everyone looks absolutely devastated to have lived through the last few hours of this course. Right now, all I see is black screens in Zoom, but if you have questions, I will be here for a few minutes. Maybe, I don't know whether Håvard will stay as well, but at least until 12 o'clock, I can stay here. If there's questions, we can be available to answer them. And as soon as we have an opportunity to get the lecture video up on the course page, we'll do that. The exercise should be all set to go, so you can feel free to get started on that. And it's due next week before class begins. And if you're going to attend the exercise sessions in person, please go and reserve a time slot in the spreadsheet that is linked in Slack. I have no idea how many people are going to want to come to those. If we have much more demand than we have space, then we'll try to figure out a solution. But I do feel we're somewhat bound by the restrictions at the university at the moment in terms of how many people can be in the classroom. Things will operate in sort of a hybrid way online, but I do understand it's a little bit different than being present in the class. Any questions at the moment while everyone is still here, or most people are still here?